In this recording, we're going to review trig concepts from Green Book Assignment number 5. We're going to go over trig graphs and identities, as well as triangle applications. That's your law of sines, law of cosines. In our first example, we have a question that asks us to find the sine of 2 theta. In other words, a double angle. So anytime you see that, the first thing you're going to want to do is write down the corresponding identity for the sine of 2 theta. And there's only one, so you can just write it out. Look on your reference sheet, it's 2 sine theta cosine theta. Next, there's a bit of information that we don't know. We do know cosine of theta is -3/4, so we could sub that in right away. However, we have to do some figuring to figure out the sine of theta in order to be able to evaluate this expression. So let's make a picture. It says it's in quadrant 2, so we're going to place the reference triangle in quadrant 2. We know that cosine is the adjacent over the hypotenuse. In other words, it's the x over the r. So we've got -3/4. Tricky here because it kind of makes you think of a 3-4-5 triangle, but it's not, because if it were a 3-4-5, obviously the 5 would have to be the hypotenuse, right? So we have to do some figuring to determine what y is here. So work it out, play the recording when you've got the exact value of y. Okay, so hopefully you figured out, you did some Pythagorean theorem, and you got that y is equal to radical 7. It has to be the positive root, because it's going in the positive y direction. Now I think we have enough information in order to be able to work this out. We now know that from our picture, we have 2 in the formula, and then it's sine theta. So sine theta is the y, which is √7, over the r. It's the opposite over the hypotenuse, times the cosine, which was given. Now we just multiply the numerators. You get -6√7. The denominators, you get 16. Simplify it, and there's your answer. In our next question, it asks to find the cosine of x minus y. Again, you have an identity that you need to reference here. So you look on your identity sheet, your reference sheet. Remember, cosine, we say sinus keeps us minus, so that means cosine does not. So it goes cosine x, cosine y, plus sine x, sine y. We have 2 of the components here. We're going to need to draw some pictures in order to find the other 2. Well, it gives us some clues. It tells us that x is in quadrant 3 and y is in quadrant 2. So again, make your reference triangles in those quadrants. 2 different pictures. So I've got an x in quadrant 3, and I know that sine is the y over the r, and because it's a negative expression, the negative has to be on the y. It's going down. Remember, the r is never negative. And the same thing for cosine. It's in quadrant 2, so cosine is the x over the r, and it's negative, going in the negative direction. So that pair of pictures looks great. Now we need to determine the unknown sides using the Pythagorean theorem. Fortunately for you, they happen to be Pythagorean triples. So do some quick Pythagorizing, or remember what the Pythagorean triples are, and fill in those unknown sides. Okay, hopefully you got -15, we're going to the left, +3, we're going up. Sub in all the stuff you know. Okay, so when we get to cosine of x, we need to look at the proper triangle. So this was the x triangle. That's why it's important to label it. It's the x angle. And cosine, again, is the x over the r. You have to remember a few things here. Negative signs, those sometimes get forgotten by students. Also, it's not the cosine of -15/17. This is the cosine of x. So cosine does not appear in here because you've evaluated the cosine of angle x. Figure out the rest of the ratios. Okay, we have ratio times ratio, ratio times ratio. Now we need to do some order of operations. Multiply before we add. So we multiply, numerator times numerator, denominator times denominator. What you'll find in these questions is, if we're dealing with cosine or sine, we always have the same denominator when we add, so that makes it kind of nice. So we've got 36/85. There's our answer. Our next question involves simplifying using a trig identity. So when I see this expression, the first thing I want to do is see if there's any obvious simplifying, and I don't see it. However, there is a square in this term, so I'm thinking I'll probably need to make use of a Pythagorean identity. So I'm going to factor the 2 out of the numerator. Okay? Factor that 2 out. Now, what I've got in red, hopefully, is something you recognize. 1 minus sine squared x is equivalent to cosine squared x. And that's great, because if I have a cosine squared x in the numerator, I can simplify it with the cosine x in the denominator. Again, we make an angle replacement here, an identity replacement, with what's in red. That's a recognizable identity there. It comes from the first Pythagorean identity, rewritten in terms of cosine squared x. Now it's an easy simplification. We just divide out the square and then the linear term, and you're left with 2 times the cosine of x. Our next question asks us to make a couple of graphs in order to determine how many times the paths of the skaters intersect. So if I'm looking at graph M, I want to identify the details of the graph, such as amplitude, period, etc. So why don't you look at each of these graphs and see if you can identify what is their amplitude. Okay, hopefully you said this one has an amplitude of 3, this one has an amplitude of positive 2. Remember, the amplitude is the absolute value of the A value. Frequency. Frequency is the number in front of x. It's the B value. It tells us how many cycles, how many complete cycles we see within a 2 pi interval. Next, the period. So the period is always 2 pi over the B value. And that's a little tricky when B is a fraction, like half. So multiply the top and bottom by 2. You guys got very good at this. So the period is 4 pi. Let's think about why that makes sense. If the frequency is half, that means we're only seeing half a wave within 2 pi. So that means it would take 4 pi to complete a full cycle, and that's what we got as the period. Finally, some notes. Over on the right we said, because of that negative, it's going to be a reflection of y equals cosine in the x-axis. And over on the left side we said, hey, when we graph this, we're going to need to use a 2 to 12 ratio to accommodate the fact that we need to go out to 4 pi. It has to graph between 0 and 4 pi. Last thing is just identify what a sine graph looks like, and hopefully you know that sine usually starts at 0, unless there's a vertical shift. There's not. And cosine usually starts at the value of the amplitude, unless there's a vertical shift. So in this case, we're going to start at -2 because it's reflected. Here are the graphs. First thing we're going to look at is that sine graph. Let's identify its critical points. So we know we're going to start at 0. We know it's going to take 4 pi to complete one cycle, so we got another point here on the x-axis. Halfway in between, we know the sine graph is going to be back to where it starts. And then we know it's going to go up to the maximum and then down to the minimum. So those are our 5 points. We just connect those points, we've got it. Finally, we're going to use another color for the cosine graph. Okay, we said the cosine graph would be starting at its minimum. Okay. And we know it's going to complete one cycle within 2 pi. So then within another 2 pi, it's going to complete another cycle. Okay. So halfway in between 0 and 2 pi, we need cosine to be up at its maximum because it's reflected. And then we have to split the difference here between 0 and pi 2 pi. Again, repeat that cycle. Goes up, down. Then just connect your points. So the question wasn't just to make the graphs, the question was how many times the paths of the skaters intersect, and we can say the paths cross twice in the interval 0 to 4 pi.